Imagine you're traveling to your home for Diwali and you stop to charge your EV vehicle and suddenly there's a 3-hour long queue. Is it because we have less number of chargers or is it something deeper? Hi everyone, welcome back to my channel Pathfinder with Yatnika. Today in this video, I'll be talking about the logistical and operational problems of the unconventional cases using the diagnose framework. So let's dive into it. So to solve these type of cases, we'll use the diagnose framework. Let's have a look at what it exactly is. D stands for data points. Don't jump to conclusions, start with facts. Ask when is the problem happening, where is it happening, how big is it increasing or is it sudden, that is the time series stamp, etc. Next is isolate segments. Now we break the problem into parts. Ask is this happening to all customers, all geographies, all product lines, etc. Then comes assumptions to test. Now we brainstorm possible causes. We don't decide yet, we only list all the possibilities. Typical buckets are demand shock, supply side issue, process failure, external environment, etc. Next is ground validation. Now we check the reality. We do the inspection and auditing of the existing systems. We check the real users, real operations, real logs, real ground teams, etc. Then we narrow to the root cause. This is the most important step. You remove weak causes, you keep only what actually explains the data. Next is options to fix. Now we design solutions and we design short term, medium term, long term solutions to fix the problems. We look at some temporary and some permanent solutions also. Next is safeguards. Now we ask, how do we make sure this problem never happens again? For example, alerts, automation, monitoring dashboards, predictive forecasting, etc. Next is evaluating the impact. Finally, we measure if solution actually worked. Real metrics could be customer experience, operational efficiency, financial returns, time, cost, etc. Now that the framework is clear, let's start solving the case. So the problem statement here is EV charging stations on highway are seeing 3-hour long queues during holiday travel peaks. We need to analyze the situation and give some recommendations. So first things first, let's ask some clarifying questions. We'll understand the business context first. Where is this issue exactly happening? Is it some highway or a corridor or is it citywide? So the interviewer says that only specific intercity holiday travel corridors of a largely populated city of India faces this issue. You can divide it into 4 tier 1 corridors with very high EV traffic and 3 tier 2 corridors having medium EV traffic. Okay, so how many stations in both of these corridors are currently in a working condition? So the interviewer says for tier 1 there are on an average 10 stations per corridor and for tier 2 it is 6. So now we'll ask a few questions on the average number of chargers per station and average time taken by each EV vehicle to get fully charged. So the interviewer mentions that there are around 12 chargers per station for tier 1 and on an average 8 chargers per station for tier 2. Also, you can divide the type of EV vehicle based on the battery size, that is small, mid, and large. The charging time taken by small batteries is 25 minutes. For mid, it is 35, and for large, it is 50 minutes. Also, what is the peak arrival rate during holidays, and what are those peak hours? The interview mentions that holiday peak is around 25 cars per hour for tier 1 and 18 cars per hour for tier 2 on an average. Also, 9 a.m. to 12 p.m. is the primary spike time, and 6 p.m. to 9 p.m. is also where we see huge traffic. Now we'll understand the constraints. What is the capex flexibility to add more infra, and are there any land constraints at these stations? The interviewer mentions they can expand around 10 to 15% chargers year on year, and only 30% stations can physically add more than 4 chargers. Now that the business context is completely clear, let's apply the diagnose framework here. We have already collected the data points in our questioning phase, so we'll directly move on to isolating the segments. We'll look at the geography. We have seen that tier 1 is the high demand corridors and tier 2 is the medium demand corridors. Let's look at the customer segmentation now. Large battery vehicles have longer occupancy, and then there are small battery vehicles. Then comes infrastructure. Here we have retrofit versus new build stations. Next, we put our assumptions to test. Here we form three hypothesis buckets. First is the demand side. There might be app routing, that is clustering the demand at these stations. Then there is holiday departure synchronization. Peak days is where we see demand surge. Then destination clustering, for example, charging in a station near a restaurant so that you can eat while your car is getting charged. Second is the throughput side. Session time is usually longer during holiday because people want safety buffer while charging their cars. Also, charging beyond 80% takes a bit more time. So 20 to 60% charges very fast, 60 to 80% is moderate, and 80 to 100% is where we see very slow charging. There could also be idle plug time where the car is fully charged but is still occupying the charger. Third is supply side. There might be infra expansion lag or constraints, grid throttling, and downtime reducing effective capacity. Next is ground validation. We would validate this using operational data, that is, the charger utilization logs, session length distribution, charger uptime logs. Next, we'll look at the behavioral data, app routing versus arrival mapping, SOC at arrival distribution, station choice versus detour distance, etc. Next is physical validation, that is QCCTV timestamp mapping, holiday peak site inspection, station staff interviews, etc. Then we narrow down to the root cause. So we already have the data points. Let's consider the share of small sized battery EVs is 35%, medium sized is 45%, and large size is 20%. And the charging times were already given to us. Considering 15% efficiency drop in charging due to hardware downtime, payments or software connectivity issues, and peak overload throttling, new charging times would be as shown on the screen. We'll take a weighted average of these numbers and we get an average charging time of about 41 minutes per EV. So service rate is 60 minutes upon 41 minutes, that is 1.46 cars per hour. For tier 1 at each station there are 12 chargers. So service rate per station is 1.46 into 12, that is around 18 cars per hour. Arrival rate is 25 cars per hour, hence there are 25 minus 18 into 3, that is 21 cars waiting in queue during peak hours in the morning, and similarly for the evening. Similarly for tier 2, there are 18 cars waiting in queue during peak hours in the morning as well as evening. So what does that mean? Tier 1 and tier 2 queues are similar in magnitude despite infrastructure differences. So the root causes are demand clustering, that is app routing and synchronized travel. Secondly, it is the throughput physics. 41-minute sessions limits flexibility. Then there is infrastructure expansion lag. There is a long-term scaling constraint. Now let's move on to the options to fix. Here we'll divide it into four parts. The first is immediate, that is 0 to 6 months of timestamp. Because infra scaling is slow, we focus here first. Here we focus on smart load balancing routing. This is the primary lever. We route demand away from the top 30% congested stations. This will help reduce hotspot queue 30 to 50% without new chargers. Next is queue prediction routing. We do route suggestion based on arrival time and predicted wait, not current availability. This prevents demand surge waves. Next is dynamic peak pricing. Higher price at overloaded stations and lower price at underused ones. This redistributes the demand. Next is throughput optimization. This will give us a very high ROI. Idle penalties, 80% charge nudges, and faster payment plus plug flow. This is equivalent to adding 10 to 20% virtual capacity. Second is targeted infrastructure expansion. Since only 30% stations can scale, we treat them as capacity anchors. The strategy here is corridor anchor expansion. Instead of expanding all stations slightly, we expand few stations massively. At expandable stations, we add around 4 to 8 chargers and prefer ultra fast chargers. We make them mega mid corridor hubs. This works because demand naturally clusters city exits, mid travel spots, and destination entries. Third is smart year on year expansion allocation. Priority 1 would be the top 20% stations handling around 50 to 60% of the demand. We get majority of new charges here. Priority 2 is corridor gap filling. We try to add new station between overloaded nodes. Priority 3 is tier 2 growth corridors. Here we start adding early before the demand explodes. Fourth is medium term, that is 1 to 2 years. Here we focus on mega charging hub model. Instead of many small stations, we build a few 20 to 40 charger hubs. Then grid partnership expansion, we pre-invest where EV demand growth is expected. Instead of 10% chargers everywhere, that gives us a very small effect. We do 40 to 60% capacity at hotspots, which help collapse the queue locally. Then we move on to safeguards. This includes real time congestion alerts. These are system notifications when station queues or utilization cross critical thresholds. App auto rerouting triggers helps automatically redirect drivers to alternate stations when congestion is detected. Holiday demand forecasting, predicting charging demand spikes during holidays using historical and travel pattern data. Station stress early warning system, monitoring leading indicators that is arrival rate, session time, uptime, etc. to flag stations likely to overload soon. Next, we move on to evaluating the impact. A few customer metrics would be queue waiting time, abandonment rate, NPS that is a net promoter score, etc. Operational metrics would include charger utilization, peak throughput that is the maximum number of vehicles served per hour during highest demand periods. A few of the financial metrics would be revenue per charger, that is the average income generated by each charger over a given period, and capex ROI, that is the return generated relative to the money spent on building charging infrastructure. So that is how you solve logistical and operational problems. In the next video, I'll be talking about behavioral and cultural problems of the unconventional cases. So stay tuned for that. Thank you so much for watching, and please hit the like button if you found this video helpful, and subscribe to my channel to stay updated. I'll see you in the next one.